Hi everyone, welcome back to Useful Genetics. This is the overview video for Module 2, where we'll be talking about how DNA molecules change and the mutations that are the consequences of these changes. We'll talk both about physical changes and the information that changes as a consequence. These changes happen because molecular machines, the machines that replicate our genes, the DNA polymerases, make mistakes in the same way that we make mistakes when we're copying text. We'll talk about the consequences of these mistakes. There's sometimes no effect at all, sometimes harmful, sometimes beneficial. And we'll talk about both immediate consequences and the longer-term evolutionary consequences, especially in the context of the importance of genetic stability, but the need for genetic variation. And we'll talk about the research significance and the personal significance of these mutational changes. Now, we'll be talking largely about information, so we'll be using a lot of the words that we use when we talk about things that we read. Talk about reading information, about copying errors and mistakes. We'll talk about looking for differences, the ability to recognize that a change has happened, to detect that an error has been made, and sometimes to correct the error. Now, I've grouped the lectures first into two lectures about mutation rates, how changes happen, why they happen at the rates they do, and why the rates are actually so low. DNA replication is an astonishingly accurate process. I'll talk about why most mutations are harmless, and we'll talk about their effects when they're in the genes that code for our proteins. We'll make the important distinction between germline mutations, mutations in the cells that we pass on to our children, and the actually much more common and much more important for our health mutations in our body tissues, our somatic tissues. These are the mutations that, among other things, cause cancer. We'll talk about how to avoid, we'll talk about what causes mutations. The term is mutagens for processes and chemicals that increase the chance of mutations. And we'll talk about what we should worry about mutations and what we don't need to worry about. We'll end by putting mutations into their evolutionary context, thinking about natural selection, the origins and changes of genes, and how DNA sequences accumulate over evolutionary time, over many, many generations, and how we can use these DNA changes to make inferences about the evolutionary history of different organisms. Now, coming up next is Lecture 2A, where we'll introduce the basics of mutations, how they happen. And we're illustrating it with a picture of DNA polymerase feeling smug because it's just proofread its DNA, caught a mistake, and corrected it. I hope to see you there.